So the first question we're asked about this graph is to calculate the total displacement over the whole trip, which is probably the toughest thing that we have to do with that particular graph. So I need to start getting shapes on here, right? Because if I'm going to find the total displacement, I need to take average velocity and multiply it by time for each section of the graph, because the average velocity is different for each individual section. Right? So getting the shapes here. And everybody's shapes might be a little bit different, and that's okay. That's all one. Hang on. That's all one. I can fix that. That a little easier. Okay. I think that'll be all the shapes we got to find. It's a lot. I'll give you that. I wouldn't give you one like that on the test, okay? But it's just good practice. Okay, so our first little rectangle here, it's a height of 3 and a base of 3, so that one will be 9. Okay, and then we've got this triangle here that has a base of 3 and a height of 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9 is 27, divided by 2 is 13 and a half. And then we've got this rectangle that goes from 3 to 10, so it's 7 on the base, and it is 12 high. I'm not doing that in my head. So that's 84 meters. And then we got this triangle here that is 1, 2, 3, 4 on the base, and goes from 12 to 27, so that's 15. So that one's 60 divided by 2 is 30 meters. And then we've got this big triangle that is 27 high by 3.5 on the base. Divided by 2 because it's a triangle. 47.25. Boy, Coderre picked some nice numbers. Okay, and then we got this little triangle here that's 1.5 on the base and negative 12. So negative 18 divided by 2 is negative 9 meters. And then we've got that triangle that goes from negative 2 to negative 12. So it's 10 high by 1, 2, 3, 4, 5. So that'll be negative 25 meters. And then 2 high by 1, 2, 3, 4, 5. So that'll be 10 meters. And then 2 high by 2 divided by 2, negative 2 meters. If your shapes are slightly different than that, that's okay, as long as you got all the area accounted for. Okay, we just have to add all those together. So, that's not 9. 9 plus 13.5 plus 84 plus 30. That's not 84, that's 81. 30 plus 47.25 plus negative 9 plus negative 25 plus negative 10 plus negative 2. Okay, I'm getting a overall displacement of positive 137.75 meters. How did we fare with that one? Anyone close? Okay, because that's a tricky one. I gave you a lot of weird numbers in there. Okay, and a lot of shapes as well. Okay, like I said, on a test, it's going to be a little more like the one I'm going to show you after this. Okay. All right, how many people are on to B, where you're calculating the average velocity over the whole trip. Okay, so what do we have to do with the number we just calculated? Divided by time. Yeah, exactly. Okay, we just calculated the total displacement. That's the heavy lifting. Okay, if we divide that by the total time, and it does seem to end here at 22, okay, we'll have our average velocity because we're just going average velocity equals total displacement divided by total time. Okay, so that number there divided by 22 seconds should give us a velocity of positive 6.3 meters per second. Okay. All right. How do we calculate acceleration on this graph? Or even in a problem? Do I have a formula that calculates acceleration? Okay, so this one that's on our formula sheet, A equals VF minus VI, and it's important you get that in the right order, okay, divided by T. All right, so acceleration between 10 and 15 seconds. So at 10 seconds, our velocity was 27, and at 15 seconds, it is negative 12. And so negative 12 minus 27. Okay, and that takes place over 5 seconds. So we've got 39, negative 39, over 5, whatever that comes out to. All right, so our acceleration during that time is negative 7.8 meters per second squared. Okay?
I think it's 28 on the graph.
Is it 28 on the graph?
Yeah.
Did I misread it? Oh, that's fine. You're totally right. I totally misread it. Okay, that makes it 40 then. It's a nice round number, right? Okay, and then we would have 8, negative 40. Okay, that would give us negative 8 meters per second squared, which is much better. Good eye. All right. How many people are done to D? All right, I'm going to give you a little bit more time then to get ahead of me. Now you've seen an acceleration one. You got another acceleration one. You got a distance one. We've already got the numbers on there, so that won't be hard now. Okay, average speed. Okay, total distance over total time. All right, give you guys a little bit more time to work on that, and I'll leave those distance numbers up. You can. Did I do this one right then? Did I keep that to 27? I didn't. I messed that one up. I messed that one up really big. And I messed this one up. I don't think I messed the other ones up, but I did mess those two up.
Isn't it 32, not 24, because 4 times
Oh, 64. I did 48. Yeah, I did times 3. Oh, man. I need another cup of coffee. Yes, 32. It shouldn't have got smaller. It should have got bigger. Yeah, 32. That one's 49. Now that I have the right number in there. I think the rest are okay, but yeah, those two I messed up. Okay, let's have a look at the next one, which is the acceleration between 6 and 10 seconds. Right, so if I'm looking to calculate acceleration again, I'm using this formula, VF minus VI over T. Okay, at time 10 seconds, we have a velocity of 28. That one I misread earlier. Okay, and then we have an initial velocity of 12. That happens here at 6 seconds. Okay, it's going over to 12, so 28 minus 12. And obviously between 6 and 10 seconds is 4 seconds. Right, so 28 minus 12 should give me 16 over 4, which should give me positive 4 meters per second squared as my acceleration during that time.
Okay, everybody all right with that one? Okay.
How many people are done E? Okay, do we want a little more time, or do you want me to go over it now? Hands up for time? Okay, I'll give you another minute or two here, and then we'll go around. Okay, let's look at distance, between 0 and 10 seconds. Did we already do the bulk of the work for that? Do we already know the displacement between 0 and 10 seconds? I mean, we know all the little pieces here, right? Okay, so we can definitely use some of the stuff we're doing. We just have to remember that everything for distance is added together, which, I mean, it's all positive on here anyway. So all I have to do is add the numbers together between 0 and 10 seconds. Okay, so that's going to be 9 plus 13.5 plus 84 plus 32. Okay, so the total distance traveled there is 138.5 meters. Okay, all we're doing is adding together the scalar quantities. All right. Okay, I'm gonna give you a couple more minutes to get the last average speed and the acceleration. Okay, you've already done most of the work for F, and G just involves using that acceleration formula again. Okay, so I'll give you a couple minutes on that, and then we'll walk through those. Okay, so for calculating the average speed between 10 and 20 seconds, average speed is always going to be the total distance divided by the total time. And again, we already did the bulk of the heavy lifting for that. We have the numbers here. It doesn't matter whether they're positive or negative because distance and speed are both scalar. Okay, so we just have to go to 20 seconds. So I take all those numbers I've got in there, so 49 and 9 and 35, right? Okay, so 93 meters, that takes place over how many seconds? Between 10 and 20 is how many seconds? 10, yeah. Okay, so we divide that by 10, we got 9.3 meters per second, okay, as our average speed during that time. Okay, so that part of it is the same as the word problems, right? We have to remember, yeah, speed is total distance over total time. I've already done the work to get it, I just have to put them together. Right? Now, the last one is asking about an acceleration part. Okay, so that acceleration is the acceleration between 13.5 and 22 seconds. All right, so 13.5 is right here. 22 seconds is right here. What's my acceleration between 13 and 22 seconds, or 13.5 and 22 seconds? 0. My final velocity is 0. My initial velocity is 0. 0 divided by anything is 0. Okay, so that one's a kind of a stinker to end with. Because it catches people, right? They figure, oh, that can't be it, and they'll go ahead and do a bunch of other things to try and figure it out. And sometimes I put in a question like that. It's a trick. It makes people think they got to do more than that. Okay. Questions on what we're doing here? Okay, we're going to have a little bit more time to practice on this because obviously tomorrow we're doing a lab on velocity versus time graphs as well. Okay. So, I'm going to give you guys about a, let's say 3 or 4 minute break here. So we'll come back at 12:55, okay, and we're going to work on some other graphs that I built here. Yeah, but they're much simpler than this one. They don't involve so many shapes that your mind gets, kind of overloaded.
Can I go back?
Yeah.
Another question.
Okay. 1 second. Okay, so the one you got on the board here is much more like you would get on a quiz or a test. Okay, there's not nearly as many little sections to do. Okay, identifying things is a bit easier on this one. Okay, so you got a velocity versus time graph, same as the one we were just working on. Okay, I want you to calculate the acceleration between 2 and 7 seconds, the total displacement over the 9-second trip, okay, the total distance over the 9-second trip, and the average speed over the whole trip. Okay, now luckily the last 3 things
all use the same work. Okay, so don't let it seem like it's overwhelming. Once you're done number 2, you're done the bulk of the work. Okay?
All right, so since this isn't one single line, okay, we can't just find the slope and have the acceleration, okay, because we're not dealing with that. But between 2 and 7 seconds, we actually do kind of have a single line, right? But we can calculate its acceleration because it's a velocity versus time graph, where I can find the final and initial velocities and read the time directly off the graph. So once again, it's a matter of identifying what kind of graph we have, and being able to determine what formula fits with what I can read off of that graph. Okay, so my final velocity is at 7 seconds, and it's -6. Okay, my initial velocity is at 2 seconds, and it's +4. Right, and that happens between 2 and 7 seconds. That's 5 seconds. Right, so I've got -10, because -6 minus 4 is -10. Okay, over 5. So I have an acceleration of -2 meters per second squared. Okay, everybody okay with what I did there? Right, just use the formula from my formula sheet with what I could read off of the graph. Okay, Cliff? Yeah, you look confused there. No, I agree.
Okay. All right, anybody else got a question on that? All right, so obviously, question number 2 is gonna take a little bit longer. You got a little bit of work to do with number 2. Okay, remember that you're having to deal with each section of the graph separately, because in each section of the graph, a different thing is going on, right? But what we are generally looking to do here is take average velocity and multiply by time, okay, to get total displacement, right, for each section of the graph. Okay, so in order to kind of tackle number 2, again, rather than memorizing, which is, oh, I gotta do the shapes because it's this kind of graph, okay, I wanna look at the graph and ask myself what's going on in each part of the graph, because that can help me to establish what I need to do for a calculation for each part, okay? So in this first section of the graph, right, for the first 2 seconds here, what's the object doing? It's traveling, yeah, its velocity's not changing, so it's moving at a constant velocity. If it was a position time graph, absolutely be not moving, okay? In this case, it's moving at a constant velocity of 4 meters per second. So does that mean that the average velocity during that time was also 4? It does. If the velocity was constant, it's also the average. So if I want to use average velocity times time to get the displacement during that part of the graph, I find the height, which is the average velocity, 4, times the base, 2. Okay? And I get that that part of the graph is +8 meters. Okay, what's going on in this part of the graph? What's the object doing there? What's its initial velocity at time 2 seconds? 4. What's its final velocity at time 4 seconds? 0. Okay, so it went from a velocity of 4 to 0. What do we call a change in velocity? Starts with A. Yeah, it's accelerating. Okay, and acceleration can be positive or negative. In this case, the acceleration is negative because the object is slowing from +4 to 0 during that time. Is it still moving forwards? It is. Okay, how do I know that? How do I know that even though it's accelerating backwards, the line is going down, that the object is still going forwards? Because it's positive, yeah, its velocity is still positive during this whole highlighted green section here. Okay, it starts at +4, it ends at 0. The whole time it was going forwards. Okay, so when I calculate its displacement, okay, I'm going to take its average velocity, which will be half the height, because it slows from 4 to 0. Okay, which means its average velocity during that time was 2. Okay, the time is 2 seconds times the height over 2, so 2 times 2 is 4 divided by 2. Okay, 2 times 4 is 8 divided by 2 is 4 meters. Right, and it kind of makes sense that this should be half of that. Right, I mean it is essentially exactly half, okay, of the area. All right, what's going on in this part of the graph? Is the velocity still changing there? It is. It goes from 0 to -6 meters per second. So it's still accelerating negatively. But now it's actually moving negatively, right? Because now its velocity is negative. So when I calculate the displacement there, I'm still going to do that base times height over 2. That's still going to be average velocity times time. But now I'm going to get a negative number because it's moving backwards, and thus its displacement should be negative. Right? So the base of this triangle is 3. The height of it is -6. So -6 times 3 is -8 divided by 2 is -9 meters. And then for this last part, for the last 2 seconds, it's traveling at a constant velocity of -6 meters per second, okay, for those 2 seconds. So -6 times 2 is -12 meters. Okay, is everybody okay with my analysis of that graph? I don't think I messed up any of the numbers this time. Okay. Now that I've got all of those, if I want to find the total displacement, what do I have to do with them? Add them all up, but making sure that the negatives stay negative, okay, because I'm talking about displacement, which is a vector quantity. All right, so I've got 12, positive 12 up here, okay, and I've got negative 21 down here. All right, so 21 minus 12, so we're looking at, oh, got 9, -9. Okay, as our total displacement over the whole trip. Okay, everybody all right with that? Okay. How does number 3 differ from number 2? I add them all up as positives, actually without any vector at all, right? Because distance is scalar. I already did all the work. Those are the right numbers, but now it doesn't matter whether I went forward or backward. Okay, so now instead of saying positive 12 plus -21, I'm just going to have 12 plus 21. Okay, and I'm going to get that my total distance is 33 meters. Okay, direction doesn't matter. Okay, and for number 4, how do I calculate average speed? What's my formula? V equals d over t. Okay, average speed equals total distance over total time. Well, I just calculated the total distance, okay, so I did all the hard work already. Total time is 9 seconds. Okay, 33 over 9. Right, so we're looking at an average speed of 3.7 meters per second. Okay,
What if on the test you would have put 3.67?
that'd be fine. Unless I specified how many decimals I wanted, that'd be fine. Just always show your work too. Okay, any other questions on that one? All right, so that's a velocity versus time graph. Last thing. Now you got a position time graph. Things are a little different. We get different things off of this graph. So we have to do things a little bit differently here. All right, you're only being asked to calculate 2 things, but you actually have to do 3 things. Actually, 4 things. 4 things in order to answer those 2 questions. All right, and give you a bit of time. See what you remember from the position time graph stuff. Okay, so we got position versus time graph, and they want to calculate the average velocity over the whole trip. Okay, so average velocity is total displacement divided by total time. Is there a second way to write that formula? How is it?
Final position minus initial position.
Right, final position minus initial position divided by time. Okay, because the other way to calculate displacement is final position minus initial position. Since I have a position versus time graph, I can get those numbers directly off of it, right? Which will allow me to plug in and solve for average velocity. So my final position is -6, okay, and my initial position is 0. Okay, so -6 minus 0, and I divide that by the total time, 9 seconds, right? So we're going to get 0.67, -0.67. Right? Okay, as as our average velocity over the whole trip. Okay? You got that one?
No,
No?
it goes 5.
Okay. What numbers did you have on the top?
-6 and 0.
Okay. What did you have on the bottom?
Oh no, I didn't. I just did -6 divided. Wait, I did -6 divided by 9.
Like that?
Yeah.
You sure? You would answer -6. So whatever, took this answer here. You put just -6 divided by 9.
Oh.
Yeah. You accidentally pressed the answer button, so there's something else in there. Had the right idea though. Okay. How is number 2 different than number 1?
Find the distance.
I have to find the total distance, and distance is scalar, so once again, I have to go back to section by section of this graph. I can't just go final position minus initial position over the whole trip now, okay? I have to do that for each section of the graph, okay, but I can't do it over the whole trip. So, how far, what am I doing here? What's the object doing between 0 and 5 seconds? It is moving at a constant velocity, right? Okay, and it goes from a position of 0 to a position of 8. I think that's 8. Yeah, okay, we'll say it's 8. If you misread it, it's fine. Okay, so that's going to be 8 meters. Then we go from 8 back to 0. Yeah, that's another 8 meters. Okay, and then we go from 0 to 6, -6, so that's 6 meters. Now what do we do here? We don't move, right, so that one is just 0, okay? So we got 16 plus 6 is a total of 22 meters. Because it's scalar, I don't need the positive on there. That takes 9 seconds, okay? So that's total distance divided by total time. That's calculating speed. Okay, so 22 divided by 9. All right, so we're looking at 2.4 meters per second as our average speed there. Okay, questions on that one? So should you expect on your quiz tomorrow questions just like those two? Expect tomorrow on your quiz questions just like those two. Okay? Simple graphs, okay? Doing exactly the same thing. Now, before you back up, tomorrow we're going to be doing the lab. And we're going to be using the little data cards that I used for the first lab, except this time you're going to use the data cards. So, you need to put on your phone, or at least one member of your group needs this app on their phone. Okay, it's free, but you need it on your phone so it'll talk to our carts. Spark View, view spelled incorrectly. Okay, Spark VUE. Okay, it's a free app. Install it on your phone. It will connect to the carts via Bluetooth, and then it will send the data to your phones, and we'll need that for tomorrow. Okay, so at least one member of your group can have that. Make sure that they do. And this is going to sound awful, and I'm sorry that it sounds awful. It is awful. The Android version of this really sucks. So if you have an Android phone, find someone in your group who's got an iPhone, because the Android version of this just does not work. Okay, I've tried it on my Android tablet a bunch of times, and it's just god awful. Okay, I don't know why they can't build something to work with Android, but they didn't. So unfortunately, we have to be an Apple snob. Okay, for tomorrow. Okay. But that's what we'll be doing after our quiz. Okay. Reminder also that tomorrow is May the 9th, so your position versus time labs are due at 8:30 a.m. So hopefully they're already done. Okay. But make sure those are submitted to me at 8:30 a.m. or before.